Hassler here. I'm going to give you a lesson on 5-6. We are actually really just reviewing things that we did back in Unit 2, only this time we're going to be looking at function notation instead of y equals. The other idea that we throw in here is whether or not something is changing at a steady rate. In other words, whether something is linear or not linear. So let's take a look. It says fluids are sometimes given to a patient through an IV using a drip machine. Data in the table show the time that has passed since administering the IV and the volume of saline in milliliters remaining in the bag. So I have this table with time and the volume left. Notice that as time passes, the volume is decreasing. It says, is the patient getting rehydrated at a steady rate, and how do you know? And so in order for the patient to be getting rehydrated at a steady rate to me sounds a whole lot like slope. And slope, if you recall, I'm going to put it in this upper corner, is change in y over change in x. So for this to be, for the IV bag to be dripping at a steady rate, my change in y here, which if I calculate that is minus 70 over my change in x here, which is 20. I'm going to do negative 70 over 20. If I calculate that, I get negative 3.5. If this is a steady rate, that means that rate of negative 3.5 milliliters per minute should match all the way through. So I'm going to check this change in y, which is negative 175, over this change in x, which is 50. And so I have negative 175 over 50. And if I calculate that, I also get negative 3.5. So that time period and amount draining matches. But that's not enough. I actually have to check all of them. So I'm going to check this here. And so the change in y here is negative 525. And the change in x here is 150. And so I'm going to take negative 525 divided by 150. And again, I get this negative 3.5. So the question again is the patient getting rehydrated at a steady rate? Yeah. Yes. All pairs of points give the same slope. If my slope would have been different between one of the pairs of points, then the answer would be no. No, because I'm not getting the same amount per minute over some interval of time. And so in order to determine whether you are changing at a steady rate, you have to find if the slope is remaining the same throughout the entire period of time. All right, 2 says, is the volume of saline a function of time? And remember, when we talk about functions, we talk about, well, is there one input to each output? So my volume is my output, and my time is my input. And yeah, each time will match with only one volume. So yes, each time period will match with only one volume. So this is a function. Some friends in class said, well, time can't repeat. So I'm not going to have the same time period matched up with two different volumes. Again, each time period will be matched to only one volume. 3 says, how many milliliters of saline are being administered to the patient each minute? Well, we actually found that part up here. The bag is losing 3.5 milliliters. That means that the patient is gaining 3.5 milliliters per minute. How do you know? We did that change in y over change in x. Okay. 4 says, let V of t be the volume of saline remaining in the bag after t minutes. Find V of 0. And V of 0 means that we're actually trying to find the y-intercept. I want to know what y is when time or when x is 0. And so that means I want to go back up to my table here and I want to figure out, hey, if time is 0, what volume does that go with? And there were a couple ways that you could figure this out. Some people were saying that, well, in a 20-minute span of time, we lost 70. But I'm going to be going backwards a 10-minute span of time, and half of 70 is 35. Since I'm going backwards, I'm going to be adding 35. So they took 1365 plus 35, and they got 1400. Some people said, again, 1365 was at 10 minutes. But I have this rate where there's 3.5 milliliters per minute draining. So I want to add back that 3.5 milliliters per minute for a 10-minute period of time. Again, you end up with 1365 plus 35, which is 1400. That's the initial amount. So it says, what does V sub 0 represent in the context of this problem? The drip bag started with 14 milliliters, or my initial amount of saline was 1400 milliliters. So the drip bag started with 1400 milliliters of saline. All right, write an equation for V of t. All right, so my equation for V of t instead is going to be in that form like y equals mx plus b. But instead of y, we're going to use V of t because that's our output. And that's equal to my slope. Now, technically, my volume is decreasing, right? I'm losing 3.5 milliliters per minute. So negative 3.5. And instead of x, I'm going to write t because that's our independent variable. And we said that we started with 1400. So that was my y-intercept. Use your equation to find from number 5 to find V of 350. Then that means I'm going to say negative 3.5 times 350 plus 1400. And if I do that calculation, I get 175 milliliters. 7 says, when is V of t equal to 0? If V of t is equal to 0, this time I'm looking for an x-intercept. An x-intercept occurs when the output, or the y, is 0. And what does this mean? So I'm going to set 0 equal to, I'm going to replace, see if V of t is 0, I'm going to replace the V of t in my equation with 0. So 0 equals negative 3.5t plus 1400. I'm going to subtract 1400 on both sides. So I get negative 1400 equals negative 3.5t. I'm going to divide both sides by negative 3.5, and when I do that, I get 400 minutes. And so after 400 minutes, the bag is empty. My volume is 0, so the bag is empty. And then finally it says, what is a reasonable domain for V of t? What is the range? So domain, remember, deals with the time or the input. And so it's reasonable to start at time 0. And I'm going to do t instead of x. And I'm going to stop at 400 because we just found out that at 400 minutes, the bag is empty. And range is that volume, my output. And it's reasonable to have 0 milliliters of saline. I'm going to say less than or equal. I'm going to say V of t instead of y. V of t is my function that we're using. And I'm going to say less than or equal to 1400. 1400 is the maximum amount of saline that we have due to the fact that that's what my bag started with. Okay. And so students worked through this problem. We discussed it in class. We then took some notes on the 5658 notes page. And so if you would like to get those notes, go ahead and watch the notes video. If you have any questions, let me know.